All right, so this will be parts 3, 4, and 5. We have to set up a zinc cell as our reference electrode for all three of these. So you'll notice that in part 3, 4, and 5, at the bottom of the first page of the lab report, we're using a 1 molar zinc cell. And then the second cell is what's changing. So these are not standard concentrations. And we're going to use the cell potential to figure out something about those standard concentrations. So in part 3, we're going to just dilute the copper solution that we have. So we have to do this by a serial dilution. And we want 1/1000th of a molar unit. It is starting at 1 molar. And so we're going to do a dilution across the top. We're going to dilute to get the final copper right here. And that'll be right next to the zinc. And then we'll also do, part 2 will be the silver chloride reaction, and that'll be here. And then part 3 will be the ammonia reaction, which will be right here. So instead of using the dropper from the copper, I'm going to pry that guy off of there. And we're going to go 5 drops. Honestly, I'm doing this from memory because I left the procedures. I've done them a long time, but 1, 2, 3, 4, 5. All right, so there's 5 drops in there. So we need to add 45 drops. That should have easily be 45 drops. So nice steady hand here. All right, there's 45 drops there. I'm going to pull this up. Squirt it back in. That kind of mixes it up. Then pull some up. Transfer 5 drops over. 1, 2, 3, 4, 5. Ideally, I'd use a brand new beaker of distilled water here, but we got to move this along. So the stock solution was 1 molar. This is now 10th molar. I just added 5 drops over here. I'm going to add 45 drops of water, and that'll put this at 100th molar. Steady hand. All right, I'm going to pull it up to mix it and squirt it back in, then pull up a small sample, get the air bubbles out so I can get 5 consistent drops. The rest back in. Uh, 45 milliliters of water. 45 drops of water. Any air bubbles. Again, nice steady hand. So we do not need that. We do not need that. This is now 1,000th molar, and that's what we're going to run the cell against. So we're going to put our zinc cell right here and go from there. So we're using 1 molar zinc solution. I'll put it to approximately the same level. So there's our 1 molar zinc solution. And there's our copper electrode. All right, zinc electrode, copper electrode. Now these probes, I can't press down on them too well, so I've got a couple of binder clips. The negative lead is the black lead. That goes on the anode. The anode is the one where oxidation occurs and zinc is being oxidized. So I'm going to pinch this on here, see if I can get it to grab hold firmly without pulling out. And then we'll put the copper over here. And then notice we have zero potential. Well, what's missing is the salt bridge. And so what we use for a salt bridge is a little piece of filter paper. And I'm just going to tear off a piece. And we're going to bend it around into the two cells. And then we're going to take our potassium nitrate solution and soak that up. All right. And now we've got a cell potential of 1.048. 1.048 is our cell potential. All right. So there we are. So in this next one, we're going to take some sodium chloride. We've got 1 molar sodium chloride, and we're going to measure 10 mils of that. All right. So there's 10 mils of sodium chloride, and we're going to add a singular drop of the silver nitrate. And so what that, I'm going to see if I can get you guys to see that on the camera or not, but right down there at the bottom, let me get that closer to the lens. Right down there floating around on the bottom is a little clump of silver chloride precipitate. See that floating around there? We're going to get that mixed in there really well. Get it kind of broken up, because we're going to pour a small sampling of that into our silver cell. Okay. We're going to do this one right here. I got to keep it well mixed as I get ready to pour some in there. We wanted to make sure that we have some of that precipitate in there with it, because that precipitate is going to be in equilibrium with this reaction. So there's plenty of precipitate in there. So there's our silver cell, here's our zinc cell, and we're going to run a circuit here. So black, the zinc is definitely the more active one. So I'm going to pinch the black lead onto the more likely to be oxidized. So I'm going to pinch that on there securely. Let's come at it from this angle. That's much better. And then we're going to bring the red lead over here to the silver electrode. And then we need a salt bridge. Notice it's still zero potential. And then we need some potassium nitrate on the salt bridge. In the salt bridge, if you will. And there's our cell at 1.076. So go ahead and record that, 1.076. And that's all we need from that one. So I'm going to leave that one set up because we're going to use that one more time. I'll disconnect this one, take the salt bridge out. And the next one we're going to do is pretty similar. Let me get rid of this one. Alright, so in this next one we're using 6 molar ammonia. Again, this is going to be in large excess. Let me clarify that. In the previous one, the 1 molar sodium chloride was in large excess. In this case, the 6 molar ammonia is going to be in large excess. So about 10 mils of this. And 1 singular drop of copper. And again, let me give you a good shot of that. See that pretty blue color there? Remember that copper ammonia complex? It looks like it's forming a precipitate. It's forming a precipitate, a copper hydroxide precipitate. But as we swirl this around so that it's in contact with all the other ammonia that's in there, you're going to see that precipitate go away. So that's the copper ammonia complex. We're going to do one more cell. I'll do it off in this direction over here. Get that black lead out of the way. There we go. I'm going to do it right over here. There we go. So there's our copper electrode. We've already got our zinc hooked up. Let's get our copper hooked up over here. And we need a salt bridge between these two. And some potassium nitrate for the salt bridge. and there's our voltage. So 0.613. Go ahead and record 0.613. All right, time to clean up.